In this video, you'll be learning to turn numbers into strings, and also migrating your project from C to C++ so we can use features such as classes. This is going to be quite a lengthy video. If at any point you find yourself lost or confused, then the GitHub link is in the description. Let's get started. Hello and welcome back. The first thing we will be doing is changing from C to C++ so that we can use some C++ features such as classes. Alright, to get started we're going to have to edit the makefile that we have with our kernel. So we'll just go into makefile and we'll edit that one. And we'll need to make it so that the source looks for .cpp files instead of .c, and we need to make it so that the target for turning .c into .obj is cpp and not c. If you would like to compile C and CPP files together, you're going to have to create a new target for CPP instead of just changing the old C target. Right, now we just need to rename our kernel.cpp file, and we need to do extern C for our start function so that our linker can find it and link it up as the entry function. Now if we try and do make kernel, we're just going to need to do one more modification to the makefile, and in the objs variable we need to change that .c into .cpp. Can't believe I missed that one. Alright, we'll try that again, and as you can see we have pointer of type void pointer used in arithmetic. Warning, that's because in C you can do that, but in C++ you can't. We also have invalid conversion from void pointer to char pointer. We're going to need to fix those. Right, so glyph buffer is a void pointer, but we can't use a void pointer in arithmetic, so we'll just cast that into a char pointer. And we also forbid converting a string constant to a char pointer. So all we need to do is take a const char pointer str instead of just a char pointer. And we just need to cast this const char pointer string into just a char pointer string, and that should resolve all of the errors. There we go. So we've compiled as C++ instead of C. Now we can run that and it should just run as it was in the last episode. As you can see, we have the exact same output as we did in the last episode. Now that we're in C++ instead of C, we can start arranging everything a little bit differently. The first thing I'm going to do is move these printing functions into a class so that it doesn't have to take all of this data every single time. The class can hold this data instead. It'll just clean things up a little bit and make it look a lot nicer. So to get started, let's create a new class and call it BasicRenderer.cpp. And we're also going to need BasicRenderer.h. Alright, now in BasicRenderer.h we need to do our pragma once, just so that we don't have multiple definitions of anything inside this header file. And now we can create our class. So we have a class BasicRenderer, and that's all we have at the moment. So now we can start moving our functions in there. So we'll declare a public tag, so all of the members that we put after this tag are public, and then we can just start moving things. So we can take this void print, move it into BasicRenderer.cpp, and do a BasicRenderer, and then 2 colons to signify that this function is part of the class, and then we also need to declare it inside the class. So we'll copy the print and all of its parameters and put it into the class. Alright, now that we've done that, we're just going to need to resolve a few things. So this class has no conception of what cursor position is, so each basic renderer is going to have its own separate cursor position. So instead of doing point cursor position in kernel.cpp, we can do point cursor position in BasicRenderer.h. And now that we have cursor position inside BasicRenderer.h, we're going to need to make it so it knows what point is. Now we can put point into a math header, so we can create a header called math.h and grab this typedef struct and put it into math.h. And while we're at it, we can change this from a C struct into a C++ struct. So we could do struct point, and then the variables. Just looks a little bit nicer to me. And we also need pragma once. Now in BasicRenderer.h, we can include math.h so that this class knows what the point struct is. And in BasicRenderer.cpp, we need to include BasicRenderer.h. Right, so now it knows what cursor position is because the basic renderer has a variable cursor position. Now it needs to know what a frame buffer is and what a PSF1 font is. So we can create a new file and call it framebuffer.h. And we need to do pragma once. And then we can move the struct of framebuffer into this framebuffer header. And we'll convert it into a C++ struct. Looks a little bit neater. And then in BasicRenderer.h we can include framebuffer.h. Alright, now the basic renderer knows what framebuffer.h is, we need to make it so it knows what PSF1 font is. Just like with the framebuffer, we can create a header file and we can just call it simple font, simple fonts.h. We need our pragma once, and then we can move our PSF1 font structs into simple fonts. Just clean them up a bit. Right. Now one last thing before I forget, instead of defining this size t ourselves, this type def, we can just do include standard int. Now standard int is a freestanding header that is with any sort of C or C++ compiler. It won't really include any extra code, it's just a couple of macros and definitions. Alright, now Basic Renderer knows what all of these variables are. It needs to know what the putchar function is, which we still have in kernel.cpp. So we'll just move that into Basic Renderer as well. So we have Basic Renderer : putchar, and then we need the definition in the header. So we can do copy this. Get rid of Basic Renderer : We also need a void in front of this print. Alright, now we should be able to create an instance of the Basic Renderer class and see if we've made any mistakes. So, we need to get rid of this, and we need to include BasicRenderer.h. Also, we need to include simple fonts in BasicRenderer.h so it knows what the font is. Alright, now we can create an instance of Basic Renderer. So, Basic Renderer, new renderer. And we can set the cursor position of this new renderer. So, new renderer.cursorposition.x equals like 15. Or we can even just do cursor position equals curly brackets 1550. So that'll set the x and the y of this cursor position struct. And then we can go new renderer.print. And then we can hand it our objects. Now we can keep it taking all of the variables as parameters at the moment just for testing, but soon we'll move these parameters into class variables. So we'll give it the frame buffer and we'll give it the font. We'll give it the color, which is 0x1FFFFFFF for white, and then we can give it the string, which is test C++ class, just as a test. And now we can compile that and see how many errors we get. Alright, so we have a little few errors. Size t does not name a type. So framebuffer uses a reference to size t, but in framebuffer.h we did not include standard int. Alright, my mistake. Size t is not defined in standard int, but it's actually defined in standard def. std-def. Right. Now we have one more error, which is just a missing semicolon in BasicRenderer.h at the end of our function putchar. Now we can make our kernel, and we can build the image. So make build image. Now running that, we should have the string printed to the screen. As you can see, we now have test C++ class at the top left of the screen, which is exactly what we were looking for. Alright, now we can start moving all of these variables into the class instead of having to pass them as parameters. So we just need a public frame buffer pointer, target frame buffer. We need a pointer to the font, so psf1 underscore font pointer, psf1 underscore font. Now we also need the color, so we'll just do unsigned int color. And that should just about be it. So we can remove frame buffer, psf1 font and color from this function and from this function as well. Now we need to actually change the source to reflect these changes. We'll just capitalize color to keep with our naming convention. And while I'm at it, I'll capitalize put char. Alright, so capitalize put char. And we need to get rid of all of these parameters. We're not using them anymore. And we need to change the references. We need to change the references to those parameters now in the functions. So frame buffer. So we need to remove the target frame buffer in the font because the putchar function already knows what they are. So putchar, the character, the cursor position, and the cursor position.y. So that's all we need. Now in putchar, we need to change the frame buffer base address to the target frame buffer base address, the psf1 font glyph buffer into the new psf1 font. Same with this one. And this reference to the frame buffer needs to be the target frame buffer. And this reference to color needs to be the new color. One more reference to frame buffer that we had in print needs to be a reference to target frame buffer. Alright, now we can get rid of all of these parameters in print. Now it's just test C++ class, but now we actually have to provide the basic renderer with the variables before calling print. So we can do new renderer dot color equals 0x ff. New renderer dot psf1 font equals psf1 font, and new renderer dot frame buffer, target frame buffer equals frame buffer. Now compiling this, it should give us the exact same result as before, except we're not passing these parameters to the print function every single time. As you can see, it hasn't changed, so we've done it successfully. Alright, but what if we forget to supply these variables? That will result in some really undefined behavior. So what we need to do is make sure that we can't forget to define these variables. We need to create a constructor for this basic renderer class. So back in basic renderer, we can create a constructor. We just repeat the class name, do a bracket, and then we need to add the parameters of everything that we need in the constructor. So we need a frame buffer, a font, cursor position can just default to 0, 0. So we need a frame buffer pointer target frame buffer, lowercase t. We need a psf1 font pointer psf1 underscore font. And actually the color can just default to white as well. So basically the only ones we need to define are the target frame buffer and the psf1 font. So now we can head back into BasicRenderer.cpp and create the implementation for the constructor. So we'll just do BasicRenderer : BasicRenderer. We need to copy these parameters that we just defined in the header. And now we can create the implementation. So target frame buffer with a capital T equals target frame buffer with lowercase t. psf1 font with capital PSF equals psf1 font with lowercase psf. The color default will be set to 0x ff. And the cursor position default will be set to 0 and 0. Alright, now if we compile this, we'll get an error because we're creating this without a constructor. See, as you can see, it says no matching function for call to BasicRenderer, BasicRenderer. And this will prevent us from making any errors regarding not giving the class the correct variables. Right, so now we can do new renderer equals basic renderer. And as you can see, we now have our definition, so we can pass it the frame buffer, and we can pass it the font. Now we can get rid of this line here, and this line here, and all of these lines. So now we just create a basic renderer using our constructor. This is stored on the stack because we don't have dynamic memory yet. And then we can print test C++ class. So we do make kernel, it compiles successfully, make build image, and we can see what that prints. Now as you can see, it says test C++ class at the very top left of the screen, which is the behavior that was intended to happen. Alright, so now that we've migrated to C++, we've made some header and some source files to clean things up. We can actually start working on some functions to convert numbers into strings. This is very important for knowing what a value is. So at the moment we can't actually display any numbers on the screen, and that is not very good. Any operating system that can't do that is not good at all. Okay, so for our toString function, we'll just create a new header and a new source file, and we'll call it cstring.h, so cstr. And we'll also create cstr.cpp, and in cstr.h, we can define our toString function. So this is converting an integer to a string. So we'll do void to_string, and we'll take we'll just include standard int.h, and then we'll take a uint64_t value, and this is a header file, so we don't need curly brackets, we just need a semicolon, and we also need our pragma once. Alright, now in cstring.cpp, I'll just close these for cleanness. Now in cstring.cpp we can create our implementation for this, so we'll make our curly brackets and we'll include cstr.h, cstring.h. Now, alright, to convert an integer to a string, we need to create a buffer full of characters. And to get those characters, we need to take each number, divide it by 10, and then the remainder is the number that we can convert to a character and put into the buffer. Alright, so the first thing we need to do is define a uint8 size. So this will be the size of the string that we are producing, like the length, number of characters in the string that there is going to be. And then we can create a uint64 size tester equals value, and we're going to use this size test just to find out how many characters we're going to need. So we'll do a while size test divided by 10 is greater than 0, size tester or size test divided by equal 10, and size plus plus. So to get the size of this string, we're just dividing it by 10, and each time we can divide it by 10, we're increasing size by 1. So that'll give us the amount of characters we're going to have. Before we go any further, we should actually define a buffer for the characters to go into. So we'll just do a buffer character int to_string output. We'll just do some capitalizing for clarity. Int toString output. And we'll make it an array of size 128, which is more than enough to hold all of the characters. We also just need to make it so this toString function returns a constant char pointer. Now we can start filling up the buffer. So we'll do a uint8 index. So that's the buffer index. That's how far we are into the buffer. So we'll make it equal 0. And now we can do similar to the while loop that we did for testing for the size, but instead of increasing the size, we can get the character and put it into the buffer. So while value divided by 10 is greater than 0, we need to calculate the remainder. So uint8 remainder equals value modulo 10. So that'll give us the remainder. So basically, if it's a number like 15, it'll give us 5. If it's a number like 127, it'll give us 7. So now we can do value divided by equal 10. And now we can put the character into the buffer. So int toString output indexed by size minus index, because we are working backwards from the size, or else our string will be backwards. So that value is equal to remainder plus the character for 0. So basically after 0 in ASCII is where all of the characters that we sort of need will be starting. That's where all the numbers are. So if the remainder is 0, it'll put a 0. If the remainder is 5, it'll go 1, 2, 3, 4, 5, and it'll put a 5. So it works quite well. And now we just need to increment index, so index plus plus. So we're now just putting all of the characters into the same index in the buffer. Now that we've reached the end of the while loop, we just need to finalize it. So we need to do uint 8 remainder equals value modulo 10. And we can get the into string output size minus index bit, and we can make it equal remainder plus 0. And we need to null terminate this string so that our print function knows when the string ends. So we'll paste that again, and we'll make it plus 1 equals 0. Now this 0 isn't the same as this 0, so this is the character for 0, which is actually 48, I believe. So now we can just return a pointer to this buffer, so we can just return int toString output. Alright, now in kernel.cpp we can include cstring.h, and now instead of printing test C++ class, we can do something like print to underscore string 1234 976. Just as an example. Just to make it work, we actually need to change this, because we changed this from a void to a constant child pointer in the source file, but we didn't in the header file, so we just need to change that. Alright, so I did do 2 mistakes here. We don't need to do remainder equals 0, we need to do remainder plus 0, the char for 0. And we don't need to minus index in this indexing, we just need to do size plus 1. Alright, now we can compile and build image. And now we should get this number printed to the screen. Now as you can see at the top left of the screen we have 1234976, which is the value that we put in there. Now we do have a conundrum though, because what if we want a negative value converted to a string? So we also need to create a implementation for a signed integer. So we'll just get rid of the u, and we'll go back into this function here. We'll copy that there and get rid of the u. And now we just need to do a little bit of a check to see if it is negative. Right, so uint 8t is negative equals 0. If the value is less than 0, meaning it's a negative value, we can do is negative equals 1. We can use this to have an offset into the buffer so that we can put a minus character in front. We can do value times equal negative 1. So we're turning it into a positive value, but we're going to be having a minus at the front, so it will be represented as the negative value. Now we just need to set the first character inside of the buffer to a negative sign. So the first thing we need to do is actually create a buffer for this function. This one needs to be a uint to string output, so we'll just copy that and change all of these int to string outputs into uint to string outputs, so that this int to string will actually work. And now we can do int to string output 0 equals the character for minus. Right, now in the indexing for int to string output, we need to add is negative plus size minus index. So this is what we have here. So we've set is negative to 1. So that'll move all of the characters in the buffer forward by 1 character to make room for our minus symbol. We also need to do it when we finalize the buffer. So we need to put it is negative plus size and is negative plus size. Alright, so now we can do toString 1234 976. And we can move on to a new line. So we'll do new renderer dot cursor position equals 0, 16. So that's 0 pixels to the right and 16 pixels down. And we can print negative 1234976. So now we can make kernel. We have a problem. Call of overloaded toString int is ambiguous. Alright, so when we actually define these, we need to actually cast them to the data type that we want. So the first one is going to be a uint64 and the second one is going to be a int64. Alright, so now we can compile and run that, and we should have the first number printing normally, just as it was, and then we have the second number, which is a negative number. So as you can see in the top left, we have the first number, and then the second negative number printing correctly. Now there's two more functions we need to make, which is printing a decimal number to the screen and printing a hexadecimal number to the screen. Both of those can be very important. So we'll create another version of toString, and instead of taking an integer, we can take a float. We can copy this function here, get rid of the guts because we don't need it like that. We're going to write a different implementation, change the buffer to float to string output, change the parameter to float, or even we can do double. We'll do double, just for that little extra bit of precision. But we also need to define how many decimal places we want to display in the string. Now a float can have, or a double even, can have so many decimal places because it's not perfectly accurate. So we need to tell it how many decimal places we want. So we'll just do decimal places. Alright, so the first thing we need to do when converting a double to a string is get the integer portion. So we can do get a char pointer int pointer equals char pointer to string, and then we can cast it to an int. So int 64 value. So that will chop off the decimal portion and give us the integer portion in a string, which is what we need. And now we need to create a char pointer double pointer equals double to string output. Alright, now we need to do our negative check. So if value is less than 0, value times equals 1. Now we don't need to do that same is negative thing that we did up here because the minus sign will be inserted when we get the int string. So now we need to copy the characters from the int buffer into the double buffer. So we'll do while dereference int pointer does not equal 0, dereference double pointer equals dereference int pointer. So just copying each character by character, and then we can increment int pointer, and we can increment double pointer. Alright, so now we've copied all of the characters of the int buffer into the double buffer. We can add a full stop to indicate that it is a decimal. So dereference double pointer equals the character for dot, and then we need to increment double pointer. So now we need to isolate the decimal portion of this value. So to do that, we just need to do double new value equals value take casted to an int value. So what we're doing when casting it to an int is chopping off the decimal portion, leaving the integer, and then we take that from the original value, and then we are left with the decimal part of the value. Alright, so now for each of the decimal places we want, we need to add a character. So for uint8 I equals 0, I less than decimal places I plus plus. So we're going through this loop once for each decimal place that we have. Now to isolate the characters of the decimal, all we need to do is times it by 10 and grab the integer portion of this value. So we'll do new value times equal 10, dereference double pointer equals casted to an int new value plus the character for 0. Now we need to take the integer portion back off this new value. So new value minus equal cast to an integer, new value. And now we just need to increment the double pointer. Alright, now we just need to finalize this string so it's null terminated. We just need to dereference double pointer equals 0. And now we can return the double toString output. Alright, now back in kernel.cpp, we can now move the cursor position down one more to 32, and we can print toString a double 13.14. So we'll do make kernel, and we have a problem. Call of overloaded toString double is ambiguous. That's because we need double value and not float value. And we also need to put our uint8t decimal places into the header declaration. So we'll just do it to 2 decimal places. I made a silly mistake here. I meant to do double pointer plus plus to increment it, but all I did was double pointer. And we also need to make sure it's times equal -1 and not just times equal 1. Now, as you can see at the top left of our screen, we have our decimal value being printed as text. So that's pretty cool. We'll also test a negative value to make sure that's working as well. So we'll just do -13.14. Alright, so now as you can see at the top left of the screen, we now have the negative decimal value printing correctly. Alright, now, one thing we need to do is just make sure that the decimal places does not exceed the amount of space we have in this buffer. So we'll just limit it to 20 decimal places. If decimal places is greater than 20, decimal places equals 20. That's just a little error check. Alright, now, it can be kind of annoying to specify how many decimal places we want every single time, so we'll just create a little default toString double function. So we'll do constant char pointer to underscore string double value, and we can return to underscore string value 2 decimal places. Now back in cstring.h, we can copy that, remove the decimal places parameter, go back into kernel.cpp and remove the amount of decimal places. That just cleans things up a little bit. As you can see, it still has the exact same behavior, but now we have the option of specifying how many decimal places we want instead of being forced to provide it. Alright, there's one more toString function we need to make, and this one is an integer toString function, but this one is printing it as hexadecimal instead of decimal. So we'll create a constant char pointer to h string to specify that it's hexadecimal, and we will take a uint64 value. Alright, now we need to create a buffer, so we'll create a buffer char hex to underscore string output, and we'll make it of size 128. 128 is just a good size, and we'll do a constant char pointer to underscore h string and our uint64 value. Alright, so this one's a little bit shorter than the other functions to program, but there's a little bit of inline maths. Alright, so the first thing we need to do is get a pointer to the address of our value. So we'll do uint64 pointer val pointer equals a reference to value. Now we need a uint8 pointer, we'll just call it ptr for pointer. We need a temporary uint8, so temp. We need the size of the string that we're going to create. Now hexadecimals, they're usually represented with all of the leading zeros not excluded, like with an int. So we will just set the size to be 8 times 2 minus 1. And that will give us enough size to display all possible hexadecimal representations of our value. So uint8t size equals 8 times 2 minus 1. Alright, so we can get into our character loop. So for uint8 I equals 0, I is less than size, I plus plus. So we're going through the loop one time for each character. Now we need to do pointer equals 2 brackets uint8 pointer, go out of 1 bracket val pointer plus I. Now we're using our temporary value, this uint8 temp here, to isolate one side of the hex value. So temp equals 2 brackets dereference pointer, and that's a bitwise and 0xf0. So that's just getting the left side of the hex value, and we need to bit shift it to the right by 4 bits. Now we can add our first character to the buffer. Hex to string output, indexed by size minus bracket I times 2 plus 1 equals temp plus, and now this gets tricky because a hex has numbers and it has letters as its representation, so we need to do temp greater than 9, so that's a conditional. So if temp is greater than 9, we can return capital A, else we can return 0. And both of those are characters, so the character for capital A and the character for 0. Now we need to get the right side of the hex, so we'll do 0f instead of f0, and we don't need to bit shift it by 4 bits. Now we can just copy this hex to string output indexing operation, and instead of plussing 1, we plus 0. Or we can just get rid of that entirely, it's up to you. Now we need to null terminate the string. Hex to string output, size plus 1 equals 0, return hex to string output. Alright, now we can move the cursor position down one more, and we can do to hstring uint 64t 0x1234. So this should print 1, 2, 3, 4 to the screen. Temp was not declared in the scope, so I misspelled temp. Just need to fix that, get rid of that E, get rid of those E's, get rid of those E's. We can make the kernel, build the image, and now as you can see, we have our hexadecimal value printed to the screen. We have all of those leading zeros because that's how a hexadecimal is usually represented. Now we don't need all of those leading zeros, we can use a smaller data type. So we'll go back into cstring.h and we need to define 3 more 2h strings. So we'll do a 32-bit h string, a 16-bit, and an 8-bit. Go back into cstring.cpp and copy this function. And this will be the 32-bit version, and we'll just do a hex to string output 32. Copy that into the function so we don't get that confused. And the size is now 4 times 2 minus 1. This will just print half the amount of leading zeros, which cleans things up a bit. Now we need the 16-bit version, so we need the hex to string output 16 buffer. And we also need the 8-bit buffer. So we'll do the 8-bit buffer, and we'll copy that into all of the references. Alright, now the value pointer no longer needs to be 64 for the 32-bit version. We'll change it to 32. We'll change this one to 16, and we'll change this one to 8. Alright, now we can test this out. So we'll print the same value 4 times, but we'll use a different data type for each time. We'll just print F0. So 0xF0. Alright, now we'll increment cursor position by 16 each time, so we'll set cursor position to new renderer.cursorposition.y plus 16 each consecutive time. So we'll copy that, so we have 4 instances, change this to 32, change this to 16, and change this to 8. Now compiling that and building that, we should have 4 representations of the same hexadecimal value, but they all have different sizes. In the 16-bit hstring function, we need to change size to 2, and in the 8-bit hstring function, we need to change the size to 1. Now, as you can see at the top left of the screen, we have the same value represented in 4 different sizes. This can be really handy when trying to display hexadecimal values. Now, there is an error. It's displaying P0 instead of F0, and that is because I made a mistake when creating the character. Instead of getting it to do the character of A, we'll just set it to decimal 55. This will translate it into the correct character that we need for the hex value. So for all of those 4 hstring functions, we'll change the character A to 55. Now, as you can see at the top left of the screen, it's correctly representing our hexadecimal value. That's pretty cool. Now, I know this was a long one. In the next video, we will be starting to look at the memory map, and we'll start looking into some simple memory functions, a little bit of paging, and possibly something else. As always, thank you for watching, and I will see you next time.